All right, hello everybody. The topic of today's brown bag is rather long. I've called it "Why do service workers break the refresh button and why it is by design?" Right at the start, let me admit that the brown bag is not a completely original work. Some time ago, I've met this article and found it really interesting. And I originally wanted to post it in Slack, but then I thought, hey, maybe not much people really open the links in the Slack, and it would be a shame to miss this opportunity to bore you. And also I realized that I was recently discussing a similar issue with Roman, and hence I decided to transform this article into a brown bag, the one and only that Roman didn't directly force me into, actually. All right, to demonstrate the problem, let's start by creating a very simple service worker that serves all the requests with a cache-first approach. So if the resource is already in the cache, it will serve it directly. If not, fetch it, cache it, serve it. At the first glance, there's nothing wrong with this code. All the resources load, even when you're in the offline mode. You'll get a nice score from Lighthouse. And it is actually the service worker that you're given by the Create React app as a default script if you decide to create a PWA. So what's wrong with it? Try to update the HTML somehow. Let's, for example, change this string to test2 instead of test1. Hit refresh, nothing happens. The old copy is cached, and you will never see the updated copy. You can hit the refresh button as many times as you want. It won't change a bit. So what can you do to fix it? I mean, on the server side, because as a developer, you typically cannot reach your users' browsers, at least not in a legal way. So the first thing that you may think of is to remove the registration of the worker. No worker, no caching, no problem, right? Wrong. It's the same case as with the updating of the HTML, because you are actually updating the index HTML, which is already cached, and so the browser will never notice that you've removed the registration. All right, so if you can't unregister it, you can try to delete it on the server. Wrong again, because the worker script has been already fetched and installed in the browser, so it doesn't really matter that it's not currently available online. It doesn't change anything. So what about holding Shift while clicking the refresh button? This approach would already require somewhat more sophisticated users, because not everyone knows that this way they can bypass the browser cache, but at least it seems to work at first, because once the user refreshes normally, he will see the old copy again. So finally, as desperate as you may be, you can try to delete the content of the service worker script, replace it with a blank file, and this will finally work, but only once the user closes all the tabs and reopens your application in a new one. As surprising as this behavior may seem, it is actually 100% by design, and in the rest of this brown bag, I will explain why. Nonetheless, if there should be just one thing that you would retain from this presentation, I would like it to be that the service workers look innocent at first, but in fact they are really complex beasts. You could have heard once that there are only two hard problems in computer science: cache invalidation, naming things, and off-by-one errors. Caching is what service workers do, and screwing up a service worker may result in your website failing in a way that is really hard to fix from the server side. The reason why the service workers behave the way they do is that they are trying to play a role of an application. If you install a native application on your favorite operating system, you typically end up with one icon on your desktop or with one new command in your terminal, which makes you feel that the application is actually just one thing, one file, which typically isn't true, because a common application is composed from a whole bunch of files, maybe libraries, maybe configuration file resources, and so on. And whenever you are updating an application, the installer typically deletes all the old files completely and replaces them with a new one. This obviously cannot happen while the application is still running, so we typically need to shut it down first before updating it. Why would you do that? Because you need to ensure that the update is an atomic operation. It either completes or rolls back, but you don't want to end up with half of the files belonging to the old version and the other half belonging to the new one, because that would most probably cause the application to crash or at least behave in all sorts of crazy ways. So what the update is actually striving for are two things: code consistency and data consistency. Code consistency is what I've just described. Either all the application files are replaced or none of them. Data consistency means that any data files, for example, I don't know, every document that you have created by your application has the expected format. And imagine that the schema of the file has changed in between the two versions. So when you're updating the application, you need to ensure that the files are migrated to the new schema, and especially that only one version of the application is touching these files at any time. Because if you upgraded the files and then they were accessed again by the old version, the application might not be able to read or write them and would probably cause some data corruption or loss. The problem is that the browser tabs do not naturally support any of these, and that's why the service workers do what they do. Because if we don't use any service worker, one problem is that two tabs of the browser may actually load different versions of your website. I admit it's not a particularly common problem, but if you open a tab, leave it be for some time, and then open the site in another tab, the versions may differ. And if local storage is involved in some sort, it may result again in the data corruption or loss. Another issue is that if we don't version somehow our resources by using a hash or a version number, there is actually no guarantee that the resources that the page is loading belong to the same version. Because we could deploy a new version in the moment while the user is loading the application, and he may grab, for example, one style sheet from the old version and then the scripts from the new one, and the application may be broken. And finally, imagine that the browser downloads the new updated index.html that requires new resources, but at that time the connection drops, making it impossible to grab these resources. And if the browser uses this new HTML, which it will probably do, the application will be broken as only the partial bundle has been downloaded by the time. So how do service workers ensure the consistency that we are looking for? If you recall my first brown bag some 1 year ago about progressive web applications, I was describing the life cycle of a service worker, explaining that it is a bit complex, but the reason is exactly to ensure this consistency. The installation lifecycle is there to bring the code consistency. When you register the worker, the browser waits for the script to download, parse, compile, which is called the installation phase, and then the API gives you a possibility to download and cache any resources that the application needs, or in case of any failure, abort the complete installation. And this is done by listening to the install event. Once the service worker is successfully installed, you might rightfully think that it would activate right away and start intercepting the network requests. But in order to ensure that there is only one version of the application running at any time, it actually doesn't. Instead, if there already is a previous version of the worker activated, our new worker enters a so-called waiting state, and it will remain in this hibernation until the old service worker dies, which only happens once all the tabs it controls are closed. The service worker API calls tabs the clients, and each browser tab, each iframe within these tabs counts as a separate client. And the old service worker stops only once when all of its clients have stopped. Once this happens, the browser provides an activate event, which is another extendable event like the install. where inside the wait until function you can do whatever you need before the new worker is ready to start intercepting the network requests, which typically means upgrading the old caches, deleting files, and so on. So we had some theory, and now back to the original question. Why is the refresh button broken? You might think that clicking the refresh button would activate a waiting service worker, but it doesn't for two reasons. First, if we have multiple tabs or clients open, we want to make sure that all these are on the same version. So we can refresh each tab as often as we like, but the old service worker has to keep handling all of them to maintain consistency. Second, even if we have a single tab, it turns out that the browser actually starts loading the refresh page before killing the old one. So as a result, whenever you click the refresh button, there are actually two clients running simultaneously. And as long as there are two clients, they must be both controlled by the same service worker. So again, it won't refresh. It won't activate the worker. I'd say that this behavior for a single tab is definitely not intuitive and may surprise a lot of developers. And what is even worse is that the burden of dealing with the situation, again, falls on us, and we are the ones that need to understand this bug and implement a fix for it. So, how to do it? Here are 4 possible approaches, sorted from the simplest and stupidest to the most evolved ones. And I will talk about each individually and describe its pros and cons. And during this discussion, we will actually dive a bit deeper into the APIs related to the service workers. So let's start with the simplest solution. In the global scope of a service worker, there is a simple one-line function called skipWaiting that, when it is called, activates the new service worker immediately after it's installed. The problem is that this completely breaks the code and data consistency. Imagine what happens if there are still tabs running on the previous version and the new worker deletes or upgrades the caches. What happens if this tab then tries to load the version 1 style sheet? At the best, it can load it from the network, which is just a waste of bandwidth. Or if the user is offline at the moment, the page will break without the user knowing really why. The worst thing actually about blindly calling this skipWaiting is that it appears to work perfectly at first. But it results in bugs in production that are really difficult to understand and reproduce. So let's try another approach. What if we still skip the waiting phase, but then force refresh any old tab that is currently open? This can actually be done pretty easily by just adding this small listener. This control change event occurs whenever there is a new active worker. And hence, once the new service worker installs, the old tabs will refresh automatically and will therefore be controlled by the new worker, right? However, it leads to quite a poor user experience because the refresh is completely unexpected, and if the user was currently doing something like, I don't know, filling a form, he will simply lose his work, and in turn, you will probably lose a happy client. So it's not a really good approach either. So let's iterate it more. What if we waited for the service worker to install, then displayed some UI saying, hey, we have a new version, please refresh, and give him some refresh link in this UI, and then we could use the same control change event, and all the tabs will be still force refreshed, but this time it will be the user who says when, so we are not risking interrupting him in the middle of something. How could we do that? So far, we have been using the service worker register call, but we are not using the return value. And it turns out that it is a promise to this service worker registration object, which is actually offering a bunch of useful methods and properties. We can, for example, call update to manually refresh the worker script. This is done automatically for every register call, but for many reasons, we may want to call for the updates more frequently, like every hour or so. We can also terminate and unregister a current worker by calling the unregister method, or we can use the active, waiting, or installing properties to get the references to the respective workers. And once we have this reference, we can communicate with the worker using the post messages. So after this small detour, let's get back to the implementation. First of all, we will add a post message listener to the service worker that will inform it when is the right moment to skip waiting. Most of the new code will, however, be in the web page, and let's start with this function. It essentially waits for a service worker in a waiting state. So it works like the registration fires an update found event whenever there is a new installing service worker. And the installing service worker fires a state change event once it is in the installed state, installed waiting state. And using this, we can listen for a waiting service worker, then prompt the user to refresh the page. And when the user clicks on the refresh link, we will send a post message to the worker asking it to skip waiting, which will fire the controller change event which we've configured to refresh the page. You may, by the way, notice this small refreshing variable which is there to prevent infinite refresh loop if you are using the refresh on update feature of the Chrome DevTools. So, how do you like this approach? On the plus side, it works even with multiple open tabs. They will all display the same refresh prompt, and if the user clicks on any of these, all the tabs will refresh and the new service worker will take control of all of them. It also seems to be a standard recommended approach actually, because Google has put together a Udacity course on service workers, and this is the approach that they document, and that occupies a significant fraction of the course, including 3 sub-quizzes building one on each other. However, it is pretty complex. You can, of course, copy this code and use it as a boilerplate, but debugging it requires a solid understanding of the service workers and the related APIs, as well as the way of testing the code and data consistency issues. Besides that, it doesn't and actually can't really fix the built-in refresh button. The user needs to use this in-app link that you have provided him. If the user has opened multiple tabs, this is actually the best approach. Probably you can't do better. But if there is just one tab, we can do better. So how? The request object has a mode property, which is mostly used for managing the security restrictions around the same origin policy and CORS with the settings like same origin, CORS, no CORS. But it has one more mode that's not like the others, and it is called navigate. When a service worker's fetch listener sees a request in the navigate mode, then it knows that a new document is being loaded. And at that point, we can count the currently running tabs, clients, with the client's API. Yeah, I know, a new API, but I promise this is the last one. So using the global clients API, the service worker can get a list of client objects. Each client has an ID property corresponding to each fetch event's client ID property, but we don't really need this now. We just need to count the clients. And from there, we can use the registration object, which is again available in the global scope of the worker, to see if there is a service worker waiting currently. And if it is, post it a message, you can skip waiting now. The only problem with this technique is that the navigation has already started. Our service worker is already handling it. And if we reply it with standard caches match, we would actually respond with the old version, because caches match always prefers to match from the oldest available cache. But the refresh page would then load the scripts and styles from the new cache, which would again break the consistency. So in this case, we'll instead return an empty response that will instantly refresh the page. For that, we will use the HTTP refresh header with 0 as the delay. So the page will appear blank for a while, and then it will refresh itself as a new version tab. And with this code in place, the browser's refresh button finally does what it is actually supposed to do, and we're using just one tab. And we can then combine it with the previous approach, so we can also handle the case of multiple open tabs. And that's finally it. I know it was pretty long, but I hope I gave you a bit more of an insight into the intricacies of the progressive web applications. And if you have any questions, now it's your time to ask them.
Is there any package already wrapping all this stuff, so we don't need to duplicate it all the time?
I don't know. I don't know of any now, because it's also split between the web page and the service worker. So I don't think so. But this is like a boilerplate that can be.
And the workbox from Google doesn't solve it.
I don't think so. I haven't seen it.
Okay, thanks.
Yeah, if you still have a tab from the old version, and the users say no, I don't want to upgrade, so it means that the tab which is on the new version cannot work either, right?
There won't be a tab on the new version. The default approach that I showed actually doesn't say to the worker you can skip the waiting phase until the user clicks this link. So all the tabs that are open will still use the same version, will be controlled by the old service worker.
Oh, I see. Or I was thinking, could we imagine a library that would maintain clones of the caches and like automatically switch, migrate from one cache to another, so two tabs from different versions can actually work together?
That could be probably also done, but the service workers are actually meant to do the other thing, to ensure that there's just one version.
All right, thanks.
All right, thank you.
Thank you, Lukáš.